Hi everyone, Mr. Eric Kua here, founder of Mr. Khemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic. Alright everybody, today we're going to go through the question from BJC. 10 years ago, this question. Okay, so ozone O3 unstable with respect to decomposition to diatomic oxygen. So what are we given? We are given the Kp, okay, at RTP. So first thing, they want us to write the Kp expression for decomposition. This should be fairly simple. We'll put the product O2 over the partial pressure of O3 and then raise to their appropriate powers in the coefficient. Okay, so you see your powers 3 is the coefficient 3 here, power 2, coefficient 2. All right, so A should be pretty straightforward. Okay, B, this question says ozone occurs quite readily in nature, most often as a result of lightning strikes. Okay, yada yada. Calculate the partial pressure of oxygen present in 6 to the power of 10 meter cube of air at RTP after a lightning strike. Assume that the atmosphere of Earth is 21%, okay, oxygen by volume. Okay, so at RTP, right, what you will do is to write down the atmospheric pressure. This we all know is 101325 Pascal. Okay, since we know it's 21% oxygen by volume, we'll just take 0.21 multiply by this atmospheric pressure and we'll get the partial pressure of O2 at RTP. Okay, so if you look at part C, right, they want you to calculate the number of ozone molecule present at equilibrium in this volume of air at RTP after a lightning strike. So after you've done up the expression, right, you've done this expression up, you've realized that what do we have? We have the Kp, we have the partial pressure of O2. Okay, so we have this. The only one that we don't have is the partial pressure of ozone. Okay, so which is what we want to find. Okay, so we sub in the numbers that we've gotten earlier. Then we can find the partial pressure of ozone. Okay, at this point, I just want to remind all of you to make sure that you know how to key these numbers into your calculator. Okay, once you got the partial pressure, right, you want to use that to calculate the number of ozone molecules. So in order to calculate the number of molecules, obviously we have to calculate the number of moles first, right? Once we've gotten the partial pressure, we're looking to convert it to volume. You can think of it as the mole fraction, the mole fraction of O3 multiplied by the volume of air. Okay, so you will get this volume of ozone. Okay, obviously you got to take that and kind of divide it by the molar volume, which is 24 dm cube, right? So once you divide that, right, this figure here, once you divide that, you will get the number of moles of ozone. Okay, once you got that, you multiply that by the Avogadro's number, you will get the number of ozone molecules. Okay, so do take note, this is the part. We actually went from knowing the partial pressure of ozone, right, to calculating the volume of ozone. And then we take that to divide by the molar volume at RTP. And then we multiply by Avogadro's number. Okay, so this set of calculation will enable us to calculate the number of moles of ozone. And then subsequently, getting the number of molecules of ozone. Okay, moving on to the last part, nitric acid, another molecule responsible is under standard condition, Kp is given. At 2000 Kelvin, the Kp actually increases drastically. Okay, from 4 times 10 to the power minus 3 to 3 times 10 to the power minus 5. To comment on the change of the Kp as the temperature rises, explain the importance to composition of exhaust gas from gas. Okay, so if temperature increases, right, your Kp increases, what does it mean? It means that in the car exhaust, right, where you have a very high temperature, right, the Kp will increase drastically, which means that there will be, this equation will shift to the right because it's endothermic, and you're going to produce a lot of this NO gas. Okay, what this means is that the exhaust gas will contain a high proportion of NO gas, as the forward reaction is favored due to a endothermic enthalpy change. Right, guys, that's all. Hope this has been helpful to you.